So the focus of this video is the nature and use of the assumed names in the two versions of the universal introduction structuring proof and the existential elim structuring proof. So first, let's review the rules, so what they look like, and what you and how you apply them. Then let's move on to a discussion of what it is that we're doing when in inaugurating or initiating a subproof, we introduce a name that has not yet been used, so a name not already in use. So first, we have the rule. On the left is the form of the rule. So your far left line is either the main sequence, or it could be a subproof sequence. It doesn't matter. What matters is that the assumptive step on the indented sequence, right? The subproof step that begins with a boxed C on the assumption we're working in Fitch, and then the predicate P and the assumed name C. That's what sets off the universal conditional, or sorry, the universal intro subproof, in this case of the conditional variety. So what you've got in the boxed in the form of the boxed letter is the Fitch program's way of of us telling the Fitch program that we are assuming a name. So having used Fitch on multiple occasions in at least, mostly in the context of Chapter 6 and Chapter 8, there's this drop-down menu when you start a subproof, and we've just ignored it, the little upside-down triangle. We've just ignored it, but now we won't. We click on that drop-down arrow, and we tell Fitch that we're assuming a name. In this case, it's C. And what we're doing is, in assuming that C is P, we're saying that if from the assumption that C is P, we can derive the sentence C is Q, it follows that every P is Q. So the idea is that when we assume the antecedent of a conditional claim and we thereby or from it derive the consequent, we get out of that subproof and say, we've just proven that if P, then Q, right? So the conditional claim on the horizontal is proven on the vertical. Or another way to say it is that the vertical P, then Q just says if P, then Q. Now the added, so you'll remember that right from Chapter 8, this is a conditional intro. The added language is this: the arbitrarily named C at the assumptive step is just assumed, it's grabbed, it's arbitrarily chosen, it's random. So what we're saying is that if we can say this, namely P then Q, about any arbitrary C, we can say it about everything. So more on that later, but that's the gist of the rule. Now the other point to make is that C does not occur outside the subproof where it is introduced. In other words, it is a hypothetical name, so it can't be used after the subproof has been discharged. We would say, another way to say this is that C is not already in use, and we won't use it once we get out of the subproof. The other version of the universal intro rule, you'll notice, involves simply assuming a name, and then from that assumed name deriving a sentence, in this case, in this formulaic case, P. So let's think about this just very briefly as a review in terms of the the legitimacy, our sort of intuitive understanding of the illegitimacy of moving from an individual to a universal, right? One of the reasons why we don't appreciate stereotypes, even if they're positive, is that it doesn't intellectually feel right for us to say that, let's say, since this person, Carlos, is wearing an LA Dodgers baseball cap, that everyone is wearing an LA Dodgers baseball cap, right? That just doesn't jive with what we think is a legitimate inference to a universal. This is why we have the assumptive proof. So when the claim that you want to prove is a universal not of the conditional variety, right? In this case, we're talking an atomic sentence, but it could be a complex sentence that does not involve the universal intro connective, or sorry, the does not involve the conditional connective. Then what we do is we simply say, well, let's say there's this name C. If from this assumed name C, I can infer that C is P, that means since C is randomly chosen, that everything is P, right? I could say the same thing about anything precisely because C is just some name I've picked. Now the same restriction applies here as with the previous version of the universal intro, namely the name that you've chosen does not occur outside of the subproof in which it appears. Now let's talk about the there's only one version of the existential elim rule. If you want to make a comparison, existential elim is similar to disjunction elim in this respect. Like disjunction elimination, which involves assuming first one side and then the other side of a disjunction that has that's been given to you or that you've derived. Here, again, when you have an existential that's given or derived, you set up existential elim. So my point in making this comparison is that, like with the disjunction, when you have an existential that's in premises, again, given or derived premises, you're using that existential to set off a subproof, rather than in every other rule that we've seen, you're using the sentence that you want to derive, typically the conclusion of the argument, to set off the structuring subproof or nested subproof as you may need it. So here we have the following. There is something S. So we're given that there is something S. Let's suppose that that something S is C. If, from the assumption that that something S is C, we can infer some sentence Q, it follows that Q. Here again, your restriction from the universal intro rule applies, namely the assumptive name does not occur outside the subproof where it's introduced. Okay, so those are the rules. Now let's talk about what we say, what we mean when we introduce an assumptive name. So imagine that we have a bucket of stuff. Let's just say that this bucket of stuff, in this bucket of stuff, is everything individually in the universe, right? So every individual entity in the universe. Now, suppose that you reach into that bucket and you grab one of those individuals. Let's say her name is Alyosha, right? So it's going to be the case then that when you reach in and you grab a name, and this name is Alyosha, you have now got your assumptive or randomly assigned name. Think about it this way as well. You weren't looking when you reached into the bucket, right? You just grabbed the name. So in this sense, it's just arbitrary. Now, you've already chosen Alyosha, right? So she's out of the bucket. What you must do if you need another name, and this sometimes happens in your derivations where you have to provide a new subproof, and that means using a new name, you can't use Alyosha. That's because you've already chosen that name. You've got to pick a new name, as we pointed out earlier, one not already in use. So say hello to Bailey. So we can't use Alyosha. There's one and only one. We must use another name. We're saying Bailey. Now, another way or to increase your understanding, so another way to understand or increase your understanding is to go back to the work that you have done and continue to do in Tarski's world. You know that the program is set up to reflect what we're talking about when we're talking about a name that can apply to one and only one object. So suppose we have this dodeck, we name the dodeck E. When we move over to the cube and we want to name the cube, notice the name E is grayed out. That's because it's already in use. Now, there may be many names E in the universe, but this feature of Tarski's world is meant to show us that there is, at the end of the day, one and only one object of the sort that we're talking about. In other words, that the identity of this dodeck is unique. That's what gives us the single use of E. So that when we want to name a cube, we've got to give it some other name. And again, once we name the cube or any other object B, that name is no longer available to us. If I introduce a new object, as I've just done, notice that not only is E grayed out, but so also is B. With that in mind, I hope as we return to our bucket of names that the single use of the arbitrary name makes more sense. So let's sum up what we've just said. And I hope that this pulls some ideas together and clarifies the point of the single use of a name in a subproof and what the hypothetical or arbitrary nature of that name is. So the thinking is something like this. If I can prove a claim about any named thing, I just grab a name, then this arbitrariness, the arbitrarily chosen name, allows me to make that claim about everything, right? So just grabbing a name means that what I can say about this, I can say about any name I would grab, hence the universal. In other words, it doesn't matter which name I pick or could have picked, since I'm able to legitimately draw the inference, the relevant inference, from the name that I did pick. So the arbitrary name is a hypothetical name. It's not quite a constant, but it's also not quite a variable either. As I like to say, it's like brunch.
Meet me tomorrow for brunch.
What's brunch?
You'd love it. It's not quite breakfast. It's not quite lunch, but it comes with a slice of cantaloupe at the end.
Now, you don't get a cantaloupe or a slice of cantaloupe at the end of your proof, but you do get your conclusion, and that's even better. Remember a comment about the last slide that the arbitrariness of the name makes sense when we're deriving a universal claim. Any random name we pick that yields the desired sentence means we can assert that sentence for every relevant thing. But let's also make a similar comment about the requirement for a new name in a subproof for existential elimination. So I want to approach it this way. The assumed name in a subproof identifies the entity as this entity and no other. This is important since the scope of an existential claim is narrower than that of a universal, right? Think about what happens when we eliminate the universal. All we have to do is remove the quantifier and instantiate the variable. That's because the scope of the universal is complete. Not so with the existential. Let's try an example to see if that helps us make our way into what it means to say that we must assume a name in an existential elimination proof, and that that name must be one not already in use. Suppose you're a medical examiner. In your work, you come across unidentified people. How do you tell the difference between them when you don't know their names? You assign them names. For example, if you have 4 unidentified bodies, you would name them, for example, Jane Doe 1, Jane Doe 2, John Doe 1, John Doe 2, and so forth. You don't know what their actual names are, so in order to talk about them intelligibly and to keep things straight, you assume a hypothetical name. Now, each one must get a different name so as not to confuse one for another. We know how important that is. When we're talking in generalities and then we move into specifics, we don't want to make a mistake in terms of the way that we're talking about these named entities. So even though a name is assumed, right, it is a hypothetical, we can't mistake what is said about one individual for what is said about another. Consider the following claim. All the corpses are ready for autopsy, but these are priorities, right? So we've got a universal claim, which means that it doesn't matter which corpse you name, you have a corpse that is ready for autopsy. But notice that among those that are ready for autopsy, there is at least one that is to be prioritized. If we name the universal before naming the existential, we may mistakenly take one of the corpses ready for autopsy to be the same one that is to be prioritized, when in fact that's not the case. So we use the existential elimination assumed name first. In other words, we set up existential elimination before we start pulling off the universal quantifiers. All right, let's look at an informal example. You might decide to either pause the video and just read the slide or read along with me, and then we'll work through it. Everyone here is either a freshman or a sophomore. All the freshmen are enrolled in Philosophy 101. Someone here is not enrolled in Philosophy 101, so someone here is a sophomore. Let's suppose it's Francisca who is not enrolled in Philosophy 101. Now, since everyone here is either a freshman or a sophomore, it follows that Francisca is either a freshman or a sophomore. Let's further assume Francisca is a freshman. So, since all the freshmen are enrolled in Philosophy 101, it follows that if Francisca is a freshman, then she is enrolled in Philosophy 101. Therefore, Francisca is enrolled in Philosophy 101. But you can't both be enrolled and not enrolled in Philosophy 101. So, someone here is a sophomore. Now, let's further assume that Francisca is a sophomore. So, someone here is a sophomore. In either case, then, someone is a sophomore. So, having assumed that Francisca is not enrolled in Philosophy 101, it follows that someone is a sophomore. Here's the argument in the notation of quantifier logic. Premise 1. Everything is either an F or an S. All F's are P's. There is something that's not a P. Let's assume from line 3 that it is F that is not a P. So notice in Fitch, the drop-down menu will yield a number of individual constants, and you pick one. I've picked F for Francisca. The next move is to start peeling off the quantifiers, that is, to eliminate the quantifiers starting at line 1. Why starting at line 1? Well, I know that line 1 involves a disjunction, and I know that whenever I have a disjunction, I'm going to set up disjunction elimination. I also know that in order to break apart the conditional, I'm going to need to, as with line 1, first pull off the quantifier and instantiate the variable. But more specifically, once I have the conditional, I'm going to need the antecedent in order to break apart the conditional to yield the consequent, at which point I will be able to introduce a contradiction. As you can see right now, it's implicit between P and not P. So at line 5, the universal is instantiated to the name F, which has been chosen at line 4. And as you already know, in order for you to work on your connectives, your constants have to be consistent. So once I have my disjunction, I'm in a position to set up disjunction elimination, right? So from line 5, we assume the first in the successive series of disjunction elimination subproofs. I assume the left side at line 6, and then I proceed to instantiate line 2, eliminate the conditional from lines 7 and 6, and then assert the contradiction between lines 4 and 8. As we know, from a contradiction anything follows, and I assert the conclusion. Another way to think of this setup is as follows. Recall that when you set up existential elimination, 99 times out of 100, the conclusion of your argument is the conclusion of the structuring subproof, the existential elimination subproof. Continuing to work backward, when we know that this sentence, the end of the existential elimination subproof, is the terminating sentence, that terminating sentence becomes the conclusion of the disjunction elimination nested subproof sequence. So once I generate the contradiction at line 9, I assert the sentence that I want, which is the conclusion of the argument. I then immediately get out of the first of the two subproof sequences for disjunction elimination, and I assume the other side of the disjunction, from which I generalize. If F is an S, it follows that something is an S. Then at line 13, I'm out of the disjunction elimination subproof, at which point I've just proven from lines 4 to 13 and the existential that set off the structuring subproof that in fact there is an S. And that's what I conclude at line 14. Now, let me direct your attention to the importance of the restriction on the name that you use when you start a subproof. Recall that the name is one that can't already be in use. And there's a reason for that. The simplest reason is this. Notice at the bottom of this screenshot, Fitch tells us, hey, you've made an error. The name that has been introduced is already in use. You can't do that. But let's think about this in, I guess, more concrete terms. So first, the error that I made started at line 4. I eliminated the universal, which by itself is not an error. I eliminated the universal at from line 2 at line 5, which again itself is not an error. Notice I get 2 check marks. The problem is that at line 6, let me go ahead and highlight this. At line 6, which is the subproof that eliminates the existential at line 3, assumes a name from which the conclusion is to be derived, I'm using the constant F. But if we go back to our original ordinary language argument, we saw that we assumed that Francisca is not enrolled in Philosophy 101. But notice here at line 4 and again at line 5, we're saying that Francisca has these attributes, is either a freshman or a sophomore, and if a freshman is enrolled in Philosophy 101. We can't say that the F that we've named at lines 4 and 5 is the same F that we're assuming at line 6. So what we have to do whenever we're going to start an assumptive proof is use a name that's not already in use. In the case of this argument, you immediately structure your proof according to existential elimination, which means you, instead of starting the subproof at line 6, you'd start it at line 4 as we did when we worked the proof correctly. So the X's that we're getting are X's that result in the rule violation, the restriction that says the name you assume has to be a new name. It can't be one already in use. Now let's move on to the universal introduction rule. There are two versions as a reminder. One is the universal intro that mirrors conditional proof, and the other is the universal intro that you use in all other instances where the step that you want to achieve is a universal. Here's an informal example of a proof that involves the introduction of a universal with a conditional as the main connective. Everyone in the room is studying hard. Anyone who studies hard is well prepared for the exam, so everyone in the room is well prepared for the exam. Now, let's suppose that Al is in the room. Since everyone in the room is studying hard, it follows that if Al is in the room, Al is studying hard. So, since Al is in the room, it follows that Al is studying hard. Moreover, since anyone who studies hard is well prepared for the exam, it follows that if Al studies hard, then Al is well prepared for the exam. So, since Al studies hard, it follows that Al is well prepared for the exam. So, everyone in the room is well prepared for the exam. Let's look at how this argument plays out in formal notation. So, you've got your first two premises. All R's are S's, all S's are W's, and your conclusion, therefore, all R's are W's. Line 3 inaugurates the subproof. More specifically, line 3 starts the universal conditional intro subproof. We assume that A is R. We're then in a position to start eliminating our universal claims and eliminating the conditionals so that we can derive the consequent of each conditional. That means that if all R's are S's, if A is an R, then A is an S. Moreover, from lines 3 and 4, we eliminate the conditional and get A is S. Line 6 is the elimination of the universal at line 2. If all S's are W's, then if A is an S, A is a W. We've already concluded or inferred that at step 5, A is an S. So, by conditional elimination from 5 and 6, we get A as a W. Now remember, since A is a randomly chosen name, it's a hypothetical, whatever we say about A, we can say about anything. So, everything R is W. Notice what happens when we violate the restriction we already know about, namely that the assumed name can't already be in use. It must be new. I violate that restriction when, instead of setting up the universal intro subproof at line 3, I first eliminate the universals at lines 1 and 2 respectively in lines 3 and 4. I'm asserting something about A that I don't actually know. Remember, A is my randomly, arbitrarily chosen name. It's hypothetical. On the assumption that, assuming that name for the predicates in question, we can derive the sentence we want, we're in a position to derive the universal. But we haven't done that within the scope of the subproof. Instead, part of that process occurred outside the subproof. And so we're extending, if you will, the understanding of that hypothetical name A outside of its restricted use. Here's another informal example of universal introduction. Everyone is a junior or a senior. Since there aren't any seniors, it follows that everyone is a junior. Let's assume there's someone named Bakari. If everyone is a junior or a senior, it follows that Bakari is a junior or a senior. Moreover, since there aren't any seniors, it follows that Bakari is not a senior. Of course, we can assume that Bakari is a junior, so it follows he's a junior. We can also assume that Bakari is a senior, but since we've already said Bakari is not a senior, it follows that Bakari is a junior. So, in either case, Bakari is a junior, so everyone is a junior. Let's look at the worked exercise. We have our two premises. Everything is J or S. Everything is not S, which is to say nothing is S. Let's assume B. Moreover, if everything is a J or an S, B is a J or an S. In addition, if everything is not an S, B is not an S. Let's assume that B is a J, so B is J. Now let's assume B is S, but that contradicts line 5, B is not S. So, since anything follows from a contradiction, B is J. Therefore, in either case, B is J. So, everything is J. Remember, B is any name we could choose. I'm not going to show you the violation of the restriction on the name. I think you've got that point by now. But I do want to offer you one more informal and formal proof of introducing a universal. Here's our last example, first in ordinary language and then worked out in Fitch. No one is a freshman or a sophomore. If no one is a freshman or a sophomore, then they're a junior or a senior. So everyone is a junior or a senior. Let's assume there's someone named Claudine. If no one is a freshman or a sophomore, then Claudine is neither a freshman nor a sophomore. Moreover, since it's the case that if no one is a freshman or a sophomore, then they're a junior or a senior, it follows that if Claudine is neither a freshman nor a sophomore, Claudine is a junior or a senior. Since Claudine is neither a freshman nor a sophomore, it follows that Claudine is either a junior or a senior, so everyone is either a junior or a senior. Here's the worked proof. Notice that the conclusion is a disjunction. In other words, it's not the case that we have what looks like the formal rule for universal intro where there is no conditional involved. So here your conclusion is a universal that covers a disjunction. Your setup is the same though as it would be if you had, for example, a universal atomic sentence. So you assume the name, in this case C, this was Claudine, and then from that assumed name you derive the sentence you want, exit the subproof, and assert your universal. I hope this tutorial was helpful in clarifying and extending your understanding of what it means to use an assumptive name in either version of the universal intro subproof or in the existential elim subproof. Stay tuned or look around for more videos that are aimed at clarifying some of the more nuanced or complicated ideas that are at work in quantifier logic.